Welcome. Today we're going to talk about analytic trig. We're looking at sum and difference identities. We're going to break it down real small though. We're just going to look at the sign of a plus b, basically the sign sum identity. Okay, we can rewrite this as that. Looks complicated, but let's see how it can be used. So, some of you might be wondering, why not just do this? Right? If you're new to pre-calculus or trigonometry, you might just say, well, can't we just distribute sine? Remember, sine is not some kind of coefficient. It's a function. We just can't distribute it. Let's see some examples, or I guess I would say counter examples. Let's do, that's sand. Why would I write that? Sine of, let's go 165 degrees. Okay, I mean, I don't know, we're just using degrees, why not? Does that equal sine of, let's break this apart, 135 plus 30? These are two rotations of the unit circle that I have memorized. I'm going to convert those into radians, so this would be the sine of 3 pi over 4 plus pi over 6, okay? So I guess the question is, does sine of 165, does this equal sine of 135 plus sine of 30? Well, this is the square root of 2 over 2, and this is 1/2. So this is radical 2 plus 1 over 2. Okay, that's if I separate them out. If we use the identity instead, I'll change colors here. Let's go use the identity and shrink down my pen. This is sine 3 pi over 4 times cosine of pi over 6 plus cosine 3 pi over 4 times sine pi over 6. I like to remember sine is like, sine likes to mix things up. So it's the sine of the first angle times the cosine of the second. And then you add to that cosine of the first angle times the sine of the second. Just flip-flops there a little bit. So this, we're going to convert into our values. Sine of 3 pi over 4 is radical 2 over 2. Sine of pi over 6 is radical 3 over 2. I'm going to add cosine of 3 pi over 4 is negative radical 2 over 2. Remember, that's in the second quadrant on our unit circle. Sine of pi over 6 is 1/2. We're going to multiply these together. I get radical 6 over 4 plus negative radical 2 over 2, over 4. That's a common mistake. This equals radical 6 minus radical 2 over 4. These are not the same things. Now remember, if we are going to talk about the unit circle, I'm just going to draw a rough one here. 165 degrees puts us somewhere over here. Yeah, that's close enough. Okay, and on the unit circle, the sine value is going to be less than 1. Or very small. It's going to be small, right? This, if, right here, our sine is radical 2 over 2. So if I just add these things together, that's going to be bigger than radical 2 over 2. Because here's radical 2 over, if you just look, I have radical 2 over 2, and I'm adding a little bit to it. Okay? What we want is actually the height of this part here if I'm making a right triangle, which is going to be radical 6 minus radical 2 over 4. Okay, that's why we don't just add them separately. We have to use the identity. So I know that was a lot to follow. We're going to do some sample problems here, so stay with me. What do you do if it's in degrees like the last one? Well, you saw me. Sine of 165 degrees. I have the unit circle memorized because it's helpful. But I don't know how many radians 165 degrees is. I can convert it, but I am just going to use, so I know that there are some degrees that coincide with some radian measures, the ones we have memorized. So 135 degrees, that's 3 pi over 4, okay? And 30 degrees is pi over 6. So I convert it, just like I did last time. Pi over 4 plus pi over 6. If I wanted to, I can add these together and find out exactly how many radians 165 degrees is, or I can convert it and that would tell me as well. Okay, so I just convert and then I get the answer. I'd get the same answer if I left it in degrees and memorized all the degree stuff. This is just easier for me to go like this and change it. So let's just do another example problem. So let's say we have, it's asking for the sine of 17 pi over 12. Well, I don't have the twelfths memorized in the unit circle. You can't simplify 17 over 12, so that's a location on our unit circle somewhere that I don't know what that is. So we can break it apart and treat 17 pi over 12 as a sum. So it looks like I can do 7 pi over 6 plus pi over 4. Seems about right, because this would be, maybe it's, yeah, I think we're good there. That's 14 12 plus 3 12ths, yep. So now that I've broken it up, I just had to double check there in my brain, I'm going to rewrite it using the identity. So I have sine of the first angle times cosine of the second angle plus cosine of the first angle, running out of room, times sine of the second angle. All right, so let's rewrite it over here, or let's replace with our values. So we replace with our values. Sine of 7 pi over 6 is -1/2, because we're in quadrant 3 now. Cosine of pi over 4 is radical 2 over 2. I'm going to add cosine of 7 pi over 6. It's negative radical 3 over 2, because we're in quadrant 3. Both sine and cosine are negative for 7 pi over 6. And sine of pi over 4, which is radical 2 over 2. Okay, multiply these together, and I get negative radical 2 over 4. Multiply these together, and I get negative radical 6 over 4. And then we just add them together. I get negative 2 minus radical 6 over 4. Final answer right there. And we don't have to simplify. This is a mathematically accurate answer. If you're asked to give an approximation or round, then you would use your calculator and get decimals. Let's do the last example. We'll do one more. Let's go why isn't it writing? Sorry. Sine of 11 pi over 12. We'll do the 12 again. You're going to see the 12s a lot. Let's see. Oh, this is 3/4 plus 1/6. Yeah, 1/6 pi. Okay, so I'm going to get sine of 3 pi over 4 plus pi over 6. Okay, and that I'm going to rewrite using my sum identity for the sine. So sine of the first angle times cosine of the second plus cosine of the first angle, remember we're going to mix it up, times sine of the second. Now the only thing that gets mixed up are the sines and cosines. You notice we have first angle, second angle, first angle, second angle. Okay, I like to write it in order. Sine of 3 pi over 4 is radical 2 over 2. Cosine of pi over 6 is radical 3 over 2. I'm adding. Cosine of 3 pi over 4 is radical 2 over 2. Nope, I got that wrong. That's negative radical 2 over 2. Sorry about that. And sine of pi over 6 is 1/2. Let's multiply it out. Radical 6 over 4 plus negative radical 2 over 4. This equals radical 6 minus radical 2 all over 4. Final answer. That's mathematically correct, and that's the exact answer. Okay, so now really our last answer. What if we are asked to do this in reverse? Let's say we have sine of 4 pi over 9 times cosine of pi over 8 plus cosine of 4 pi over 9 times sine of pi over 8. Well, if we know the identity, we can quickly identify which two angles are involved. We have 4 pi over 9, and we have pi over 8. So the first thing we're going to do is rewrite it using the identity, right? So this would be near our last step. So the one before that, we condense it down. We know this is a sum identity for sine. So I have sine of 4 pi over 9 plus pi over 8. I know it's a plus because with sine, plus goes with plus. Plus is in between the two terms here, so it's in between the two angles. Now we just add this together. So 4/9 plus 1/8, I can ignore the pi's and just do old school math. So I got 32 on the left plus 9 on the right, all over 72. This is 41 over 72. Okay, so I'm going to use this and plug it back in here, and I get sine. What's the sine of 41 pi over 72? Also, if you don't know these, you can break these apart further and further until you can get ones where you have the identity. But this is just an exercise to go in reverse. I hope this was helpful. If you have any questions, you know how to get a hold of me.